Ever thought about what it takes to start a plane? It's not like turning a key like in your car.
No.
We're talking magnetos and spark plugs and sometimes even like mini jet engines powered by air to get them going.
Yeah.
And different planes need different starting systems, right?
Oh, yeah.
A little Cessna versus a jumbo jet. Totally different.
Oh, absolutely. Yeah, it's really amazing how they tailor those systems to the specific needs.
Okay, so let's start with something a little bit more familiar. Spark plugs.
Okay.
We know those from cars.
Right.
But what's different about the spark plugs in a plane?
Well, I mean, at a basic level, they're both doing the same thing.
Creating the spark.
Yeah, they're creating that spark that ignites the fuel and air mixture.
Yeah.
But aircraft spark plugs, they got to be much tougher.
Yeah, I imagine.
They have to withstand intense heat and pressure inside a plane's engine,
Right.
without failing. So they're typically bigger, more robust, and made of, special materials that can handle that kind of stress.
And those materials make them last longer.
Oh, yeah, absolutely. Durability is key when it comes to aircraft spark plugs.
Makes sense. You don't want one of those giving out, mid-flight.
No, not at all.
So I've always wondered, what's the deal with hot and cold spark plugs?
Right.
Is it literally like temperature?
It's a little bit confusing because it's not about the actual temperature of the spark plug itself.
Okay.
It's about how efficiently it transfers heat away from its tip.
Oh, okay.
So a cold spark plug dissipates heat more quickly,
Okay.
which is really important in high-performance engines that run hotter. You can kind of think of it like if you're working out really hard, you need to cool down faster to prevent overheating.
Oh, okay.
Same idea with spark plugs.
So it's more about keeping things cool under pressure.
Yeah, exactly.
I wonder if my mechanic has ever thought about that with my car.
It's absolutely a factor in cars, too. The wrong heat range can lead to pre-ignition, which can actually damage your engine.
Oh.
So mechanics, they consider your driving habits, the type of car you have, even the climate you live in,
Oh, wow.
when they're recommending spark plugs.
Really?
Yeah.
Interesting. Okay, so the spark plug creates the spark.
Right.
But where does the electricity for that spark come from?
Right.
That's where these mysterious magnetos come in.
That's right. Magnetos are really the powerhouse behind the spark.
Okay.
They're like self-contained generators that produce the high voltage needed to make those spark plugs fire.
So the plane makes its own electricity.
Yeah, in a way. It's pretty cool, huh?
Yeah, it's pretty cool. But how does that actually work?
Well, the magneto is connected to the engine, and as the engine rotates, it spins a magnet inside the magneto.
Okay.
And this spinning magnet interacts with coils of wire, and that induces an electrical current.
Okay.
And at just the right moment, a set of points called breaker points interrupt that current flow.
So interrupting the current is important.
Yeah, so think about it like suddenly shutting off a faucet. That sudden stop in the flow creates a surge of pressure, right?
Right. Yeah.
It's the same with electricity. By interrupting the flow, the magneto creates like a rapid collapse of the magnetic field, and that induces a much higher voltage in a second set of coils.
Oh, okay.
And this high voltage is what travels to the spark plugs and creates the spark.
Okay, so the timing of those breaker points is very precise.
Absolutely. It's all about precise timing.
Yeah.
The breaker points have to open at the exact moment to generate the strongest spark. If they're off even slightly, it can cause weak sparks, misfires, or even engine damage.
Wow, so the magneto generates the electricity, the spark plug makes the spark.
Right.
But what gets the engine spinning in the first place?
Ah, that's where the starting systems come in.
Okay.
There's a few different ways to get a plane's engine going. Some smaller aircraft use electric starters, similar to what you'd see in a car.
Okay.
But for larger planes, especially jets, you often need something more powerful.
And that's where those little mini jet engines come in.
You got it. Those are called pneumatic starters. They use compressed air to spin a turbine, and that turbine rotates the main engine.
So it's like a small, powerful fan to get a much larger fan going.
That's a great analogy.
Cool. But why compressed air?
Well, a couple of reasons. Pneumatic starters have an incredibly high power-to-weight ratio.
What did that mean?
It means they pack a lot of punch for their size, and that's super important in aviation, where weight is always a major consideration.
Right, because every extra pound affects your fuel and how far you can fly.
Exactly.
So compressed air is like the lightweight powerhouse.
You could say that, but there's more to it than just power.
Okay.
Pneumatic starters are also known for their reliability.
Okay.
And they have some really cool safety features built in.
Like what?
Well, for one, they have a special section on the drive shaft that's designed to brake if the starter gets overloaded.
Okay.
It's like a fuse in your electrical system.
Uh,
Protects the engine and the starter itself from damage. And then they also have these things called magnetic chip detectors.
what are those?
So imagine tiny magnets placed in the starter's oil system. If there's any metal debris in the oil, it sticks to these magnets. Then the mechanics can check these detectors during routine maintenance.
Oh, that's really cool. So it's like an early warning system.
Exactly. It's a simple but effective way to catch potential problems before they become major issues. It's all about preventative maintenance and ensuring the safety and reliability of the aircraft.
Wow, that's really incredible. I always thought of spark plugs as pretty simple things,
Yeah.
but it's amazing how much complexity and engineering goes into just getting those engines started.
It's the whole system working together, really.
Yeah. Now I'm even more curious about those dual ignition systems you mentioned earlier.
Yeah, dual ignition systems are all about redundancy and safety.
Okay, I think we need to take a deeper dive into that because having a backup system in the air seems pretty important.
Absolutely. We can definitely unpack all the details of that next. Yeah, you're absolutely right about backup systems, especially when you're talking about, thousands of feet in the air.
Right.
That's where dual ignition systems really shine.
So remind me again, why do planes need two ignition systems?
Right.
Isn't one good enough?
Well, in theory, yeah, one system could work, but think about it.
Okay.
What happens if that one system fails?
Right, you're in trouble.
You're in a very precarious situation.
Yeah.
So dual ignition systems provide that critical redundancy. If one system goes down, the other one is there to keep the engine running.
It's like having a spare tire in your car.
Exactly.
Huh.
You might not need it often, but when you do, you're really glad you have it.
Yeah.
And just like you check your spare tire occasionally to make sure it's in good shape, pilots and mechanics rigorously test both ignition systems
Okay.
to make sure they're ready to go when needed.
So is there two of everything?
Yeah.
Two sets of spark plugs, two magnetos.
You got it. Most planes with dual ignition systems have two complete and independent systems.
Wow.
Two magnetos, each connected to its own set of spark plugs.
Okay.
This means that each cylinder in the engine is getting two sparks, one from each system.
So double the sparks, double the safety.
Exactly. It's all about minimizing the risk of a complete engine failure. And this redundancy is especially important during critical phases of flight like takeoff and landing.
Right. Okay. That makes sense. So how does the pilot control which system is active?
Right.
Is there like a switch?
There is. It's called the magneto switch.
Okay.
And it's usually pretty simple. It allows the pilot to select either the left magneto, the right magneto, or both.
So they can run on one magneto, the other, or both at the same time.
That's right.
Why would they ever choose to run on just one?
It's all part of the pre-flight checks and, ongoing engine monitoring.
Okay.
During these checks, the pilot will run the engine on one magneto at a time.
Okay.
And then on both. And they're looking for a specific drop in RPM, which is the engine speed, when they switch between magnetos.
RPM, that's revolutions per minute.
That's right. The engine speed is measured in revolutions per minute, or RPM.
Yeah.
And during magneto check, the pilot will switch from both magnetos to just one
Okay.
and observe how much the RPM drops.
So why does the RPM drop when they switch to a single magneto?
Well, because you're essentially going from two sparks per cylinder to just one.
Okay.
With only one spark plug firing, the combustion isn't quite as efficient, so the engine speed drops slightly.
Okay.
So a small drop in RPM is normal.
Good.
But if the RPM drops too much, we call that a fast drop, and that could signal a problem with one of the magnetos or its associated wiring.
So it's a way to catch a problem early?
Exactly. It's like a built-in diagnostic tool.
Okay.
It's a simple but effective way to monitor the health of the ignition system and make sure everything is running smoothly. And speaking of running smoothly, I think it's time we address those powerful jet engines and how they get started.
Yeah, we've been talking a lot about propeller planes. I'm curious how those massive turbine engines come to life.
Right.
They don't use magnetos, do they?
That's right. Turbine engines, like the ones you see on jetliners, use a completely different type of ignition system. It's called a high-energy capacitor discharge system.
So it's not sparks from spark plugs?
It still involves sparks, but it's a much more powerful and controlled process.
Okay.
It all starts with a capacitor. Think of it like a really powerful battery that can store up a massive amount of electrical energy.
Oh, okay.
And when the pilot hits that ignition button, all that stored energy is released
Okay.
in a very short, intense burst
Okay.
through a special type of spark plug called an igniter plug.
Okay.
And this creates an incredibly powerful spark that ignites the fuel-air mixture in the combustion chamber.
Wow. Why'd they need such a powerful spark for a jet engine?
Well, it comes down to the extreme conditions inside a jet engine.
Oh, okay.
The air is compressed to incredibly high pressures and temperatures,
Right.
so you need a really intense spark to ensure reliable ignition. And at high altitudes where the air is thin, it's even more challenging to create a spark that can reliably ignite the fuel.
Right. So it's like trying to light a fire on top of Mount Everest.
Exactly. You need something extra powerful to get it going.
Yeah. Okay, so you mentioned special igniter plugs.
All right.
What makes them different from the spark plugs we've been talking about?
Well, igniter plugs are specifically designed to withstand that intense heat and pressure inside a jet engine.
Okay.
They're built much tougher,
Okay.
and they have a unique feature called a constrained gap.
Constrained gap. What's that?
It basically means the spark occurs a bit further away from the main body of the plug,
Okay.
outside the combustion chamber liner.
Okay.
And this helps keep the plug itself cooler and prevents erosion and damage from that extreme heat.
Oh, okay. So they found a way to protect the spark plug from its own spark.
Exactly. Very clever engineering.
Yeah.
And just like with reciprocating engines, turbine engines often have multiple igniter plugs per combustion chamber for redundancy.
Okay.
This ensures that even if one plug fails, the engine can still start and run reliably.
So it's the same principle of redundancy,
Exactly.
but with a much more powerful ignition system.
Exactly.
Okay. I'm starting to see the pattern here. Safety and reliability are paramount.
Absolutely. Always.
Okay, so before we move on, I want to go back to something you mentioned earlier. You said flashover.
Right.
What exactly is that, and why is it a problem?
Flashover is a phenomenon that can occur in any ignition system, whether it's in a car, a piston engine plane, or a jet engine.
Okay.
And it's basically what happens when the high voltage intended for the spark plug finds an unintended path to ground.
So instead of jumping the gap between the electrodes, the electricity takes a detour.
Exactly.
Okay.
Imagine a wire with frayed insulation. The electricity might arc through that damaged insulation to a nearby metal part instead of flowing through the wire as intended.
So flashover is like an electrical short circuit.
That's a good analogy. And in an ignition system, flashover can cause all sorts of problems. Weak sparks, misfires, even damage to the ignition system components.
Okay.
And it can be caused by things like dirt, moisture, carbon buildup, cracks in the insulation.
So it's like having a leaky hose.
Exactly.
The water's not going where it's supposed to.
Exactly. That's why mechanics are so meticulous about keeping the ignition system clean, dry, inspecting for cracks and damage, making sure all the connections are tight and secure.
Okay.
They're constantly on the lookout for anything that could lead to flashover.
Makes sense. You don't want stray electricity causing problems when you're trying to get a plane off the ground.
Absolutely. It's all about attention to detail and preventative maintenance to ensure those sparks are flying exactly where they should be.
So we've covered a lot of ground here. Dual ignition systems, jet engine ignition, flashover.
We have.
It's incredible how much technology and engineering goes into something as seemingly simple as creating a spark.
It really is.
So I'm curious, what's next? Are there any new and innovative ignition systems on the horizon?
That's a great question. The world of aviation is constantly evolving, and ignition systems are no exception.
Right.
Engineers are always exploring new ways to make these systems even more reliable, efficient, and powerful. One area of active research is laser ignition.
Laser ignition, that sounds pretty futuristic.
Yeah, it does, doesn't it?
How would that even work?
Well, instead of relying on a traditional spark plug, imagine using a highly focused laser beam to ignite the fuel-air mixture.
So it's like a super precise, high-tech lighter.
You could think of it that way. Laser ignition has the potential to offer even greater precision and control over the combustion process,
Okay.
leading to improved efficiency and reduced emissions.
Are there any other promising technologies?
Another area to watch is the development of ignition systems specifically designed for electric aircraft. As we transition towards more sustainable aviation, electric propulsion systems are going to become increasingly important.
Right.
And they're going to require their own unique ignition and starting procedures.
Makes sense. So it seems like the future of aircraft ignition is going to be just as innovative and fascinating as its past.
I think so. It's an exciting time to be following these developments.
But for now, I think we've covered the basics pretty thoroughly.
We have. We've explored the key concepts from those simple yet crucial spark plugs to the complexities of dual ignition systems and the power of jet engine ignition.
Yeah.
And we've learned how mechanics and engineers work tirelessly to ensure these systems operate flawlessly,
Right.
keeping us safe in the skies. Yeah, it really is a fascinating area.
It is. And, thinking about all these different systems,
Yeah.
it seems like there's this common thread
Yeah,
of safety and redundancy.
you're absolutely right. In aviation, safety is paramount.
Right.
That's why you see dual ignition systems, backup magnetos, shear sections, and starters, magnetic chip detectors, and just really meticulous inspection procedures. It's all about minimizing that risk of failure and making sure the aircraft can operate safely and reliably.
So with all this talk about redundancy and safety, has there ever been a case where both ignition systems failed in a plane?
It's extremely rare, but yes, there have been instances where both systems have failed. Remember those breaker points we talked about in magnetos?
Yep.
Those are mechanical components, and like any mechanical part, they can wear out or malfunction. If both sets of breaker points happen to fail at the same time, you could lose both ignition systems.
Wow. So what happens in that situation?
Well, it depends on the aircraft and the situation. Some aircraft have emergency backup systems, like a small, independent, battery-powered ignition system that can be activated in case of a dual magneto failure.
Okay, so it's like the ultimate backup to the backup.
Exactly. It's there for those incredibly rare scenarios where everything else has failed. But the good news is that dual magneto failures are exceedingly uncommon. The systems are designed with such a high level of reliability and are so rigorously maintained to prevent that type of failure.
That's good to know. It sounds like there are multiple layers of protection built in to keep those engines running.
Absolutely. That's the beauty of aircraft engineering. It's all about anticipating potential problems and designing systems that can overcome those challenges, even in the most extreme situations.
Well, before we wrap up, I just want to say it's amazing to think about all the ingenuity and attention to detail that goes into every aspect of aviation, from the smallest spark plug to the most complex jet engine.
It really is. It's a testament to the brilliant minds who've dedicated themselves to pushing the boundaries of flight and making air travel safer and more reliable.
I think we've covered just about everything we can, from those simple spark plugs to the complexities of turbine engine ignition. It's been a really cool journey exploring the world of aircraft ignition systems.
It has. And I hope everyone listening now has a deeper appreciation for all the technology that keeps those engines roaring and those planes soaring through the sky.
Absolutely. Maybe next time you're on a plane, you'll take a moment to think about all those sparks flying and the incredible engineering that makes it all possible. Until next time, happy flying.